Came here to talk to you a little bit about, the title is Securing Clojure Web Services and Apps with Friend. What I first want to do is clarify exactly what I mean by securing, just because that's obviously an overly broad term and means far too many things, is very overloaded. But actually describing what I'm going to be talking about in a subject line would be impractical. So first, let's say what we're not talking about. We're not talking about most of the range of security concerns that a practical web application in the modern era needs to deal with. That includes things like SQL injection and all of its cousins, things like CSRF, replay attacks, and all the fun that goes along with thinking about and dealing with untrusted code evaluation, jailing, security around consuming serialized data formats, all that stuff. That's what we're not talking about, so if you thought that's what we were going to be talking about, now is an excellent time to make a break for the exits. What we are talking about, though, are two things. First, authentication, which is thoroughly concerned with the identity of a user or user agent that's talking to your web application or service. That's identity. And authorization, which is orthogonal to authentication and is concerned with what that user or user agent is allowed to do within your service, within a particular context, location, time of day, whatever the requirements are of your particular circumstance. And these are often conflated and often confused, but they're two very distinct topics, and they need to be treated thoroughly separately in however you implement authentication and authorization for your applications. So we'll be talking about them very, very separately throughout. So just as a matter of review, talking about what options there are in the Clojure space when you're building a web application for addressing authentication and authorization. And some of these are historical, some of them are current. I used Spring Security for years. I came from a heavy JVM background, and really the best option when you're building Java web apps, or generally speaking JVM web apps, maybe in a polyglot environment, is Spring Security, because it has, despite all of the baggage that it brings to the table because of the Spring mechanism, it does have a large community of providers that build plugins essentially into that core framework that allow you to bring in things like OpenID, OAuth identity providers, and things like that. So it's more a matter of the ecosystem driving that usage. This is serviceable to use within a Clojure web application. I wouldn't recommend it at this point, but you can certainly do it if you're masochistic, I guess. Brenton Ashworth, some years ago, built something called Sandbar. It did a number of different things that you might need to do within Clojure web app development. One of them happened to be concerned with authentication and authorization, and a lot of people have used that over the years to good effect, and you still can use it, although I'm not sure if it's maintained anymore. And then there are a couple of different identity provider specific or authentication method specific projects out on GitHub. These are just two that I happened to snag, one for HTTP basic authentication and the other for OAuth 2. And these work well for the use case that they're designed for. Obviously, an HTTP basic authentication library is not going to help you particularly much if you want to do interactive username password authentication. And so on. But the most common thing that I see people using when building Clojure web applications and dealing with authentication and authorization is everyone builds their own set of solutions for these problems. And this is sort of the worst case scenario for everybody involved, because even though authentication and authorization are probably the most, at this point, rote topics within the security, the sphere of security concerns, some of which I enumerated previously, you can still screw up badly in implementing them and open yourself up to some pretty serious consequences in that way. So none of these options are particularly fulfilling for me and in my applications. I wanted to have that capability, those capabilities of Spring Security and the ecosystem of all those different identity providers, but I didn't want to deal with Spring, obviously, on a continual basis. But the native Clojure authentication and authorization options really weren't hitting the sweet spot of providing all the functionality you might need for a practical web application, and doing so within a set of particular design constraints or matters of taste, perhaps, that I think are sort of important. And so if, for those of you that know me reasonably well, you know that I can't see a ill-shaven yak and pass it up for too long. So the inevitable happened, and I started work on a project to address these concerns in a more comprehensive Clojure idiomatic way. And just to underline the point, why do you want a common library, or if you want to say it, framework for authentication and authorization? It's because implementing both of those are, again, very high risk. You can really hose yourself badly if you do it wrong. There's minimal reward in you implementing it yourself or using ill-tested solutions. No one is going to pay you more money for your service because you get these things right. But if you get them wrong, you'll be hurting. And again, solving these issues well is absolutely necessary for any kind of serious web application. And honestly, we need to have this be a solved problem. Clojure web application development is a great experience overall, but this was just one particular vertical within that subdiscipline that was needing a little love. And just to underline the point, if you look at the other options in other language communities for solving these problems, they have super comprehensive, well-tested solutions. So, for example, EveryAuth is a Node.js authentication and I believe also authorization library for Node.js. And this is, I think, just a subset of the identity providers that it has support for, either out of the box or within the ecosystem that is around the library. And this is sort of stunning insofar as it totally eliminates that point of pain and that dealing with this domain when you need to work on your own domain. Obviously, Node.js has its own concerns and is really focused on web development as a primary domain, but we need to get this taken care of and not be working on our own so much. So, on a practical standpoint, what are we looking for in a Clojure auth library? One thing I wanted to do is assume ring. That should be obvious at this point, but by assume ring, I also mean to provide the functionality in a sort of follow ring's best practices in terms of having all of the pieces involved mesh in with all of the middleware and handlers and transports that are available within the ring ecosystem. That means not having, for example, as other libraries have done, have like a mutable session map where your users' authentication and authorization credentials go through the course of your request response cycle, which a lot of frameworks do and can be very convenient, but we sort of want to have something at the bottom that you can build those kinds of things on top of. Again, I want to be able to use any authentication authority that I want, from major services to username, password, to things like OpenID and OAuth, and then also be able to, if I need to, and if the requirements demand it, implement a authentication strategy, essentially, on my own. So this can sometimes be necessary for statutory purposes. So banks and certain financial institutions are statutorily required to do things for phishing prevention. And this is why you see in most bank logins, you provide your username, and then it moves you into an interstitial page where it shows you this icon that you chose previously, and then you need to put in your password. It's actually not a particularly good solution for phishing prevention, but that's statutorily required, and you need to implement that if you're in that domain. And again, other things that are more useful within authentication, like multi-factor, so that when you're logging into an application, one of the steps in getting to the point of having credentials registered for your session is you might get a text message on your phone that you've pre-registered with that service, and you need to enter that unique token in that login process. And then again, on the authorization side, we really want to have these things working in conjunction, but also provide a set of flexible options for implementing authorization. One of the simplest and probably most widely applicable things that takes care of 98% of people's requirements in this area is role-based authorization, and we'll talk about that more, but then also leave room for people to implement whatever ACL or capability system scheme that they want or need within their context. So, with that lengthy background, perhaps to justify why, again, I'm shaving this thing, I released Friend first about a year ago or so, and it's seen pretty good uptake. It's fundamentally a piece of Ring middleware that establishes a context for authentication within your application, one or many contexts actually. And authentication workflows, some people call them strategies, for logging in via HTTP basic versus OpenID. They are implemented as essentially just Ring handlers with a little bit of extra stuff off to the side, and we'll see what that implies. And in good Clojure form, all of the things that you can use to parameterize how Friend operates within your application are just functions. So things like hashing, credential sources for looking up credentials in databases and verifying that sort of thing, they're just functions. And again, hashing functions are functions like bcrypt, or if you need SHA-1, that would just be another function that you use whatever implementing library in the background, but Friend just needs a function. So it's fairly easy and should be familiar to Clojure developers that are used to that kind of workflow. So in terms of what Friend includes today, it includes a set of basic authentication workflows that covers 95, 98% of the typical use cases that you see out in web application development, the typical username, password, interactive login, things to support sort of basic best practices for securing authenticated access for API clients, so HTTP basic over SSL, for example. And then it also includes a OpenID workflow that gets you access to the identity workflows of Google, Yahoo, WordPress, AOL, and so on. And then I mentioned that you can require something to go over SSL because you don't want credentials flying over the wire in clear text most of the time. And so there is a little piece of middleware that's off to the side that you can do to enforce that a request or a user session gets bumped off to a HTTPS server that you have set up, or separate service. And then on the authorization side, role-based authorization is baked in and provided, and it's based on top of Clojure's ad hoc hierarchies, which are the foundations of multi-method dispatch, and I'll talk about that a little bit more when we look at the code. And there's a whole bunch of functions, macros, and Ring middleware that make applying authorization policy within different contexts of your web application really straightforward and very easy to understand when you look at the code. But also, again, to support people doing things like ACLs and capability systems and so on, you do have arbitrary imperative control within the authorization context. So you can do whatever checking you need to anywhere in your application to determine if a user is authorized to perform a particular action, and if not, there's just a function within Friend that will throw control back up to the middleware and send them a 403 unauthorized or whatever other page you want to display in that case. So let's take a look at the architecture of how the system works. Again, workflows are just ring handlers with a little bit of extra semantics to them. So a ring request comes in, and the workflow needs to determine if it contains credentials that are verified or can be verified. So for example, if an HTTP basic request comes in that has credentials baked into it, and you have that workflow set up within that context of your application, then it'll check those credentials, and if they check out, rather than the workflow function returning a ring response, it will return a map that contains a whole different set of keys that constitute the authentication for that user, and that would include things like the token that identifies the user, any user attributes that you've loaded from a database, for example, that you need to access, and that gets dropped into the ring request that gets passed down through your application handler, so you always have that available. And then for more sophisticated workflows where it's not simply a single request that comes in to authenticate a user, so for example, if you're doing a multi-factor authentication workflow, there's a number, one-to-many interstitial pages that the workflow needs to take control of outside of your handlers for your application in order to deliver those interstitials, take in those requests from those interstitials, like entering a PIN number from an SMS message or verification of a CAPTCHA, for example, and verify those. And at some point, you will get the final request in from that multi-step workflow, and you'll get that authentication map out of your workflow, and then flow will, control will flow back into your application. So that's the basic architecture of Friend. You don't need to know any of this if you're just a user. This is for the benefit of people who are either going to be implementing workflows on top of Friend, which is very welcome at this point. We certainly are far from having that grid of identity providers built out for Friend. But if you're just a user, all you need to know is the way to configure this set of workflows, and we'll talk about that too. Something is going wrong. Oh dear. That wasn't supposed to happen. So here's not quite the simplest usage of Friend, but it's pretty close. And so we'll go through each of these top-level forms in turn. Won't take very long, and it's pretty straightforward. First, an NS declaration that brings in the necessary namespaces, and then that ring app var. That's just a placeholder for whatever your application is. You always have a top-level handler that is the result of composing together all the different handlers for your ring application using Clojure routes or other pieces of middleware applied to different parts of your application. At a certain point, you have a top level that outside of Friend, you would just hand that off to a ring adapter, like the Jetty ring adapter, and off to the races you go. That's your top level. Next, we have what we're doing here is we're using the ad hoc hierarchies within Clojure to assert the relationships between different roles within this particular application. So the way you can read this is that the users with the student role have those capabilities within your system in addition to those granted to the user role. And the administrator has its capabilities in addition to those of the student and the transitive dependencies thereof. If you haven't looked at using hierarchies for modeling these types of trees and graphs in order to derive relationships in this way, I encourage you to do so. And this is a really natural way to model role-based authorization. So right here is a dummy sort of in-memory user database. Again, it's just this is my credential function that I'm going to drop into the Friend middleware. And this sort of is standing instead of a function that, given a say username, go look that up in an LDAP service and return back a map like this one that has the hashed password to be verified, the roles that the user has, and you can see Jane down here has some application-specific slot called year that will be used in a little bit. And then the final bit here where everything comes together is you now define a new top-level handler as opposed to just your Ring app. You now have secured app, which is the result of applying the friend authenticate middleware to the top level of your application-specific top-level handler, and then just a bit of configuration. So again, bringing in the dummy in-memory user database, and we're going to be using the bcrypt credential function, which is provided within Friend that uses bcrypt to do hashing and verification of passwords. And then we can specify however many workflows that we want to have applied to that scope of your application. So you can have multiple applications of Friend middleware in entirely independent portions of your application and apply different policy to each of those pieces, and then use just typical Ring composition of handlers to just bundle those all up into a top level over here. And in this case, we're bringing in the interactive form workflow that does the username and password validation. And say we have some support for HTTP basic API clients, and they're going to be using the same credentials as our interactive users. And so we just drop that in place. And so these workflows are going to be called in sequence on every request within that context. It's essentially a separate set of routes that sit off to the side that has the semantics that I talked about before. And that's about it, yes. So you need at least one workflow. Oh, and again, because you can apply Friend to multiple independent portions of your application, you can just have, say, one portion of it needs to have API authorization, but one doesn't. You can have this configuration map without the HTTP basic workflow, define somewhere, use it, and then in the portion that does have that HTTP basic API authorization requirement, you just drop that workflow into the vector. And so you can reuse configuration for Friend pretty straightforwardly that way. And bear with me momentarily. Okay. So that was authentication. Authorization is, again, entirely orthogonal, but still, from a sort of ergonomic standpoint, authorization failures just roll back up to the closest application of the Friend authentication middleware. And so in order to determine whether a user is authorized to perform any particular action or to control whether a particular chunk of code will execute within your application, you can use a couple of different strategies. So this first route up at the top here is using a macro called authenticated. All that is going to do is verify that the Ring request coming in has some authenticated associated with it. It doesn't check for the presence of any particular roles or other conditions. It's just, it won't allow anonymous users to provoke the evaluation of the body of code within the macro. Course schedules and admissions routes here, respectively, allow only students and administrators to access those routes. And this is compared to other options where, for example, you have a separate policy established for authorization for different routes within your application. A lot of frameworks in different languages, you'll define a pattern for the URI for which these sets of roles apply, and so on, and that's generally kept separately. The nice point about having this inline as a macro the way this is here, you see straight away who is able to access and cause the code within these bodies to evaluate. And I believe that's a benefit insofar as it maintains consciousness of the security implications of the code within those bodies. And then this last route here, freshman orientation, this is an example of using arbitrary authorization criteria in order to determine whether a user or user agent can cause the evaluation of some particular set of code. So we get the identity from the request, and then the condition is whether either the person needs to be an administrator or they need to be a freshman student. So we check that the request has the student role and that their year value, again, remember in our dummy user database, Jane has a year value of 1, and so she's a sophomore. And so she would not be able to access the freshman orientation route here. And then the throw unauthorized is where the action happens of creating an exception of a particular type that gets thrown up and caught by the next level up, or the closest friend authenticate application within your middleware application within your Ring app. Something bad happened to my slides. Okay. So I'm going to very briefly run through a demo or two here. You can follow along if you like. Oh, this is never going to do. So there's a set of very small, tiny really, demonstration applications that use Friend and demonstrate its capabilities at friend-demo.herokuapp.com. And each of the demos is annotated with a link that goes straight to GitHub so you can see how things work. And we'll just look at, say, the interactive form authentication here. And again, it's just a typical username, password field, they log in, and then all this demo app does is echo back the role of the user that I just authenticated as. So I'm authenticated as a user. We'll go over here and try and access this URI, which requires an admin role, which I don't currently have. So when I try to go there, I'm going to get bounced out to whatever page or route that I define within Friend to display 403s, and that's configurable. And the last demo I'll do is just go through the multi-factor authentication to give you a sense of what multi-factor authentication is if you're not familiar with it. So for example, logging in here will require that I first provide my username, and if this were a real application in the background, you would use, say, something like Twilio to send a text message to the user using a phone number that you had previously captured in the registration workflow to create that user. They would get it on their phone, and then they would input it along with typically a password and maybe other identifying credentials here. So I can not enter the PIN properly, and it'll bounce me out. And this is an example of the multi-factor workflow function going through that interstitial multiple times. And so you have control within that workflow function of how the user flow works within the authentication process. And now I'm here, and again, I'm just echoing back some stuff that I happen to have put into the dummy user database that I'm using. So you can feel free to check out. Feel free to check out this site, friend-demo.herokuapp.com. This is probably the easiest way to get started with Friend, because you can. So we'll go look at the OpenID here. There's a View Source button, big in the right. So if you like or need a particular type of authentication, you can go click on that. It'll drop you off into GitHub, and you'll be able to see exactly how any particular authentication workflow is applied, and then a variety of different usages of the authorization capabilities. And so this is the OpenID, and it's pretty straightforward. Most of the content of the demo apps are hiccup content for generating the presentation pages. So in terms of where Friend is now and where it's going, it's been out for a year or so. I released it at the end of March last year, and it seems to have gotten a fair bit of pickup. It's sort of the nature of security libraries and applications that often you don't hear about who's using your stuff and whether it's succeeding. You only find out if things are failing badly, which I haven't, which is nice. And actually, a couple people have taken a look at the Friend code base, and from what I understand of their backgrounds, it's worked out. They think it's well put together, and so I have some degree of confidence that we're not failing badly in the ways that you don't want to. And actually, Clojure uses Friend for all authentication and authorization, whether it's through the website or when you're deploying libraries through Lineage. So it's definitely being used. So coming soon, the OpenID workflow is in the Friend project itself. That's problematic only insofar as there's a whole boatload of Java dependencies that implement the OpenID stuff. And if you're not using OpenID, you don't want to cart those around. So we're going to factor that out into its own project. I'm trying to sort of build some momentum for people putting together CAN support for things like OAuth 2 providers, as well as OAuth 1 providers for those that do that, like Facebook. So that we can get closer to that grid, so that someone coming into the community that needs to build a Clojure web application and they need Facebook, Google, and username password authentication, they can just pick from the menu. That's the goal from that perspective. There actually is a little bit of room for simplifying the contract of the workflow functions. It's already pretty simple and quite easy, as the architecture diagram hopefully shows. It's just a ring handler with a little bit extra. But I think there's a way to pare that back a little bit, and this is actually a little bit pending now due to the stuff around pedestal and async ring changes that I definitely have not digested yet, but we'll see how that pans out. And again, I'm always looking for people that do have security expertise to look at the code base of Friend itself, as well as individual workflow identity authorization providers. You can never have too many eyes and too many formal audits when you can get it for this sort of project. That's it. I can take questions for a bit, I think. Yeah, so the question is does Friend contain any support for encouraging or enforcing best practices for storing passwords and other credentials in databases? It does not. Friend is actually very small on its own. It, I think, is 2 namespaces, probably a total of 400 lines, and it's really meant to be the smallest possible thing that can stack on top of Ring to solve the immediate problem. Best practices around dealing with credentials and hashing and storage thereof and aging of passwords and resets and all that stuff. All that is so application and domain specific that I'm guessing that Friend itself is probably never going to have that baked in. Although it'd be great to have a whole set of libraries that do provide that kind of best practice, so that people can again choose from the menu. Here's what I need to do. This is a library that does it right, and hopefully is parameterized for like what database backend you're using and that sort of thing. So that'd be great to see, and hopefully we can get more security conscious libraries sort of circling the wagons here. Yeah. Right, yes. Just use bcrypt. It works. It's not fast, which is awesome, and work factors and all that good stuff. So if you're using SHA or something else, don't unless you need to for some horrible reason. There are some statutory requirements for using stuff like SHA, which is amusing, but yeah. So the question is, what did I think of the pedestal talk yesterday, and how the changes that it implies to Ring, how that's going to affect Friend and things like that. Honestly, I don't know yet. I found out when you did. And from what I understand, Friend itself is small, and its contracts are very straightforward, and I think it'll the separation of enter and leave that can be then composed into a compatible middleware for typical synchronous usage. That should be straightforward. I think, knowing what I know right now, my biggest concern is how it will complicate the contract of the workflow functions, because my understanding and my expectation is that most authentication that is a synchronous operation. So, for example, for user-facing stuff, authenticating once and then getting your session populated with credentials, that's a one-time thing that happens synchronously, and I think should be able to stay that way. Stuff like API clients doing HTTP basic, maybe that's different in some way because the authentication and the response are within the same cycle, and so maybe there's implications there. But my biggest concern is just applying more complexity to that workflow contract, which is already, I've already tacked one thing on top of it just being a ring handler, and so I'm wary of it, but again, I haven't looked at it at all, so. Yeah, so the question is, would it make sense for Friend to bring in support or otherwise enable the implementation of identity providers like for OAuth 1 and 2 and OpenID and all that? No, just because that's a whole, being an identity provider is a whole nother domain from really the 99% case of I don't want to be an identity provider, I want to consume other people's identities or maintain my own identity store through a username, password, that sort of thing. So I think there's a ton of room for something like Cloth or whoever else to really bring together a very mature and reliable like OAuth 2 provider for Clojure. That'd be fantastic, because the other options in the JVM space aren't exactly great from our perspective, and so that'd be great, but it definitely doesn't belong in Friend. Yeah, so the question is, right now implementing something like ACLs using Friend's authorization functionality, you sort of need to do everything on your own to pull together the user credentials or identity, the resource sets associated with it, the action, and then determine whether they're authorized or not. Would Friend be a good place to have some sort of best practices for that? Something that people can deploy readily? Yes, that would be fantastic. It's a domain, it's a much broader and more complicated question than the role-based authorization, which is why I haven't put something down, because I'm taking the approach that whatever has landed in Friend, I can say this is, not to make a pun, the authoritative way that you should be doing something within this domain. So I'd love to talk with other people. I mean, I've done ACLs myself on top of Friend, but I've done it the way I think it should be done, and maybe there are better ways. And I'd like to hear from people that have done, a couple dozen of those and know what should be in that space. Any others? No? Thank you.